Hello. Oh. If folks are leaving, just a reminder, if you have a green lanyard, you need to return that to security, and then also find a Meta employee to escort you out, if possible. I think there's some hanging out in the back. Thanks.
Hello everyone, I'm Naveen. I work for IBM on their What's Next Data Presto and Velox team. I'm here with Apurva to present about the Iceberg V3 features that we have been implementing recently. So the first set of features that we go through will be default values and the row lineage feature, and that our team has been developing at IBM. And the next will be presented by Apurva, which is on the deletion vectors and a little bit of implementation details on that, and the variant and nano timestamp support that he has implemented. So the default values support has been implemented to support the schema evaluation scenario. So Iceberg V3 introduces these two values for a column, the initial default and write default. Initial default is used to fill in the default values for the rows which are already existing after a column is added. And the write default will be used to fill in the value if the value is not supplied during ingestion for this column. So we have added support for alter table add column to set the default value in Presto. This is just an example of how it works. So we've inserted two rows in the table, and then we just added a default value for the new column, and we see that the select actually fills in the values, the default values for the existing rows. And for any new rows that we insert, if we are supplying the new value, we are going to write that value instead of the default value. So the third statement shows that we have supplied the value for the new column, and then the query after that will show the value that we have supplied in the insert statement. So right now the support is there for only reading the initial default value, and writing the value using the write default is not yet supported. That will be coming soon. So the next feature is the row lineage tracking column read. Iceberg introduced row ID and last updated sequence number for row lineage tracking. Row ID is the unique identifier for a row across the life cycle, and last updated sequence number is tied to the snapshot that a row has been added or modified in. And that's how it's computed is shown on the screen. So row ID will be generally, we don't write it when we add the rows. We just compute it on the fly using the first row ID from the manifest and then the row position in the data file. But once you do modify the rows, when you're writing into a new file, you actually materialize the row IDs and last updated sequence numbers onto the disk. So this example shows that we are inserting 2 rows in 3 batches, and we see that the last updated sequence number and the row ID is appropriately read for all these rows. So I'll give it over to Apuva to present on what he has been working on.
Thank you, Naveen. Okay, so like Presto currently supports V2, and it also supports like V3 now, like internally at least for the Java version. But when it comes to Presto Velox, where we have CPP workers, we still don't have V3 support yet. So we started working in March, and so far we have added Delta. I'll talk about what we have added, but at a high level, what's the difference between V2 and V3 is fundamentally we should know. The first biggest difference is the deletion vectors, like how deletes work in the new version. And Iceberg V2 tend to use like equality and positional delete files. V3 also use files, but it's a different file. It's not a Parquet file. It's a new file format called Puffin. And inside files, we don't store row ID and row position anymore. We just store the bit map. So that's why it's very compact. And that's why it's called roaring bitmap, because it's a super compressed format. And in terms of other major differences, the conflict resolution. So V3 introduces a notion called data sequence numbers. So every snapshot will have its unique sequence number, and that's how like the conflict resolution happen. It's still optimistic concurrency control, but we have a well-defined identifier that helps facilitate that, instead of just doing metadata comparison at runtime. And there are multiple data types that have been introduced, like variant is another big one, and timestamp nano is another one. So TLDR is like V3 delete metadata files are like very cheap. Like they are like 10 to 30x smaller compared to the V2. And the read lookups is big of 1. Reading from bitmap is just reading from an array. It's pretty cheap. The other difference is like in V2, whenever we have mutations, whereas let's say you are setting some primary, or not the primary, some unique key to some different values, or non-unique key as well, you'll have per row, you'll have one like delete file. In V3, you'll not have that. Per data file, you'll have one. So the order has changed from per row to per data file. That's the constraint for V3. So that's why you'll have lesser number of files and lesser number of storage in those files. So it's a double win when it's compared to V2. So let's dive into the Puffin file format. So let's say we have this file called data1 Parquet, and inside there we have this simple bitmap. And let's suppose the row 4 is deleted, so we'll just mark it as 1. And similarly for like other rows, whenever we have a new snapshot, we can keep on, like per snapshot, per data file, we'll have a new Puffin file. And it has been already been instrumented in Velox already. So Velox stack is completely is feature complete for DVs at least. And we have open diffs for Prestissimo and Presto Java. And once this lands, hopefully within a couple of weeks, this should be a feature complete. In terms of if you do a big O of n comparisons, so equality deletes and positional deletes, those are the primary two mechanisms, as I said in V2. Like Iceberg V2, and those were like of the order of big O of n plus m. In the V3, we only have big O of n due to big O of 1 lookup in the bitmap. So it's like very cheap to do deletes. And similarly, updates in the new V3 world is implemented using 2 phases. First is the marking the bitmap for the delete vector, and then we create a new data file. As you might know, like files in Icebergs are immutable, so we don't change it in place. So we create a new version of a file, and in the metadata we reference both the files. And when there is a merge on read, we just apply the deletion vector on top of the previous version. to get the new data. It's like a new set of rows. So in terms of conflict resolution, like I said, there is a new notion called a sequence number. So let's say multiple concurrent writers are trying to write, like they're reading the same table, and let's say the sequence number at that time was 5. And let's say writer A commits some like insert, and writer B is doing some delete. So should B's delete be applied on A's insert? The answer is an invariant that V3 has introduced called only like when the sequence number of the delete file is less than, the data file sequence number, if it's less than the delete file sequence number, then only the mutation is applied onto the new snapshot. Otherwise, if this invariant is not satisfied, we will not do it. And this is how the sequence number is flowing through the stack. We have made changes to both the, like Presto Java, we have like introduced sequence number there. We have wired those through to Prestissimo and used those in the Velox stack. And we support all kind of snapshot operations. So we'll be supporting like all these methods on the left side. We have like a rollback to particular snapshot. We'll also be supporting expiring a snapshot. If you want to read metadata table, these are the two like tables that are available, like table $snapshots and table $history. And if like time travel is something you care about, that will also be like you can always go back to a particular snapshot and see what were the actual data files and what were the actual values inside those data files. You can always go and read, given that they have not expired. And the second thing is we can also do this time travel query, which is pretty popular. So that is also supported. And this is an example of the snapshot lifecycle. So suppose we have an insert where we have 3 different values, and then you do a delete operation, and one value got deleted out of it. And then if you do an insert at the snapshot number 3, you will see the the values have been updated just based on because the sequence number of the data file is less than the like S1 is less than S2, so data file S1 and delete bitmap S2 is less than, so it applies to the S3 as well. And in the time travel also, the reverse sequence follows. So whatever the invariant is still maintained. The next thing is the new V3 types, like variant type and the timestamp nano. And variant type is already, I have a diff for this, and it's already like an open PR on GitHub as well, which it is fully supported now. We have made, ideally variant should be mapped to var binary, but there was a discussion around open source, like multiple committers wanted it to be mapped to JSON, just because they can use existing Presto functions like JSON extract. And variant being fully compliant to JSON is something that they cared about, so that's why we decided to use JSON as the mapping type for variant. But we can still typecast to other types as well. Presto still supports a microsecond level precision. So even though we have timestamp nano available in the native Iceberg library, we have some lossy conversion here. But as a community, we can decide if Presto wants to support this nanosecond level precision. I think this is something we can discuss and change our code to. So like I said, the changes have been across the stack. Like it has been across Presto Java, Prestissimo, and Velox. And the planning and the parts in the planning phase happens in the first layer. All the plumbing happens there. And then the Prestissimo just converts the Presto to Velox conversion. And the Velox stack is where all the DV and the data file manipulations happen. So what's next for Iceberg v3? So we are actively rolling out as we are speaking. Like all these changes are getting pushed. And we are actively writing devs for this. And hopefully within a month at max, we should have at least a full DV support at least. And so that all your DDL, DQL, and DML operations should fully be supported. And this is the GitHub issue where both IBM and Meta are collaborating, and we can always follow the progress there. And here are some of the key contributors from IBM and Meta. Okay, yeah, thank you.